So we are asked to differentiate this equation, which is the natural log of x plus 1 plus y, which is equals to x y minus y power 3. So to do this, we need to have some ideas on how to differentiate natural logs. Then we also need to have some ideas on how to differentiate implicit functions. Okay, so to start with, whenever you have a natural log function, for instance natural log of u, for you to differentiate this one, we say the derivative of this natural log of u with respect to u is going to be the derivative of u, which is the function. So the derivative of u, which is the function, it will be u prime over the same function, which is u here. If it is not natural log, for instance if we had something like a log, where it was supposed to have something like natural log of the base, let's say base a. That's if it was the natural log of something to base a. But since it's natural log where the base is e, this part is going to be a 1, so no need of writing it here. So we are going to have that this is how we differentiate natural logs. So in our case here, for our equation, we are going to have natural log of x plus y. We are supposed to differentiate the inside function, then divide by the same function. So differentiation of the inside function, we do it be part by part. So it will be differentiation of x, which will be 1, plus differentiation of y, which will be y prime, then everything over the same function, which is x plus y. Okay, so after that we can move to the other side of the equal sign, where we are supposed to differentiate the product of x and y. So since we know that these terms are multiplying, we can use product rule, where we let u be equal to one of the variables, let's say x, then v equal to y. So we are going to find u prime with respect to x, it's going to be 1, then v prime with respect to x is going to be y prime. These two, when you our derivative for just x and y is going to be u prime multiplied by v plus v prime multiplied by u, meaning that we just get these values here and plug in the equation to find what we want. In this case, our u prime is 1 multiplied by our v, it's y, plus our v prime, it's y prime, multiplied by our u, it's x. So to differentiate x, y, we use product rule. So we come back to our equation, we say derivative of x, which is 1, multiplied by y, which is y here, then plus derivative of y, which is y prime, multiplied by x, it's x here. After that, we go to the derivative of y to the power 3. To differentiate this one, first we put them in parentheses so that you can clearly see. So we have y to the power 3. So differentiating this one, you drop the power, it's going to be 3. Then we have a y here inside, then you subtract 1, we're going to have a 2. Then since this is the chain rule, y is some other functions, we are supposed to differentiate the inside also. So you multiply by the inside differentiation, we get y prime. After that, we put in our equation, meaning it's going to be minus 3y squared y prime. After reaching this part, all we need to do is make y prime subject of formula. So I'm going to multiply everything by this denominator here, x plus y. So we have everything multiplied by x plus y. What we'll get here, this x plus y and this x plus y will cancel out, meaning I'm going to have 1 plus y prime is equals to, multiplying it to this side, I'm going to have x plus y open y plus y prime x minus 3y squared y prime here. Since we only want y prime to be on the other side, I'm going to open the parentheses, meaning I'm going to have y plus y prime, which is equals to x multiplied by y, I'm going to have xy, then x multiplied by xy prime, I'm going to have x squared y prime. This x multiplied by 3y squared y prime, it's going to be minus 3x y squared y prime. Then multiplying y throughout also, I'm going to have y squared plus y times y prime x, I'm going to have x y prime, then y times negative 3 y squared x, I'm going to have negative 3 y power 3 y prime. Then these all terms that have y prime, I can take them to one side, meaning that I'm going to have 1 plus y prime, then we have a y prime here, taking it to this side, it's going to be negative x squared y prime, then we have a y prime here, it will be positive 3x y squared y prime. Then we have a y prime also here, taking it to this other side, it will be negative x y y prime. Then we have a y prime here, it will be a positive 3y cubed y prime. This will be equal to everything that is remaining, and that thing is xy, which is xy here. What else? We have y squared, so plus y squared. Anything else? Okay, nothing. Meaning that from here we can take this one to this other side, or we say we subtract one from both sides. We're going to have y prime minus x squared y prime plus 3x y squared y prime minus x y y prime plus 3y power 3 y prime, which is equals to x y plus y squared minus 1. Okay, so reaching at this point, I'm going to check for those terms that are the same, of which terms that can easily subtract from this other side. So we only have a y prime here, x squared y prime, you have 3x, this can subtract, xy here, it also can't subtract with anything, this one. Okay, so all we are remaining with is to factorize our y prime. So you have y prime here, open. When you remove y prime here, we're going to have 1. When you remove y prime here, we're going to have negative x squared. When you remove y prime here, we are going to have plus 3xy squared. When you remove y prime here, we're going to have negative xy. When you remove y prime here, we are going to have 3y to the power 3. Then everything equal to x y plus y squared minus 1. Since we only want y prime, we can divide throughout by this whole term here. So dividing throughout, we are going to have y prime, which will be equal to x y plus y squared minus 1. Then everything over, we have 1 minus x squared plus 3x y squared minus x y plus 3y power 3 here. So Having found this, we can say this is our first derivative of the equation.